Hello students and welcome to Math Weekly number 16. In this Math Weekly, our focus skill will be on angle measurements of intersecting lines. In this Math Weekly, we're going to look at a lot of different types of angles. The first of which are called adjacent angles. Adjacent angles share a common vertex and a common segment. The angles look side by side. Here are an example of two adjacent angles. You can see that angle 1 and angle 2 both meet at a common vertex, which is B, and they both share this side, segment BC. Now, we could refer to angle 1 and angle 2 as being adjacent angles, or we could use their letters to name the angles. So angle DBC, referring to angle 2, and CBA are adjacent angles. Notice that two of the letters are the same. They both contain segment BC because that is the segment that they share. The second type of angles that we're going to look at are supplementary angles. These are two or more angles that sum 180 degrees. The angles always form a straight line. For example, this straight line, line KI, is formed by two angles. The two angles that form line KI are called angle JHK, which would be this section here, and JHI, which would be this section here. And together they form a straight line, which is 180 degrees, and that's why these two angles are called supplementary. The next type of angles that we're going to talk about is complementary angles. These are two or more angles that sum 90 degrees. In other words, they form an L shape, also known as a right angle. Here is a visual of a pair of complementary angles. You can see that overall they make an L shape, but that L shape is made of two parts, this part and this part. So if we were going to name these two complementary angles, we would say angle ABC, which would be this section here, and angle CBD, which would be this section here, are complementary because they form a right angle. The last type of angles that we're going to talk about in this video are vertical angles. These are congruent angles formed by intersecting lines. They are opposite of each other in location. So for example, if we have these two intersecting lines, angle 1 and angle 3 are considered to be vertical angles because they're across from each other over the vertex. Likewise, angle 4 and angle 2 would be vertical angles, and they would be congruent to each other across that vertex. So angle 1 and angle 3 are vertical angles, so are angles 2 and 4. Now we're going to review one concept from a previous Math Weekly that you may need to use to apply to this Math Weekly, and that is the triangle angle sum theorem. Remember, the three internal angles of a triangle will always equal 180 degrees. So for this picture where we have three angles within a triangle, angle A, angle B, and angle C, the measure of angle A plus the measure of angle B plus the measure of angle C will always equal 180 degrees. So let's practice finding these different types of angles. Let's first look at our picture. We can see we have lots of points, we have two lines, and we also have a ray, and there's lots of angles being formed here. So let's find a pair of adjacent angles, two angles that are side by side. Let's begin right here with this piece. Let's call this angle BCF. Can you name an angle that is beside angle BCF? We'll just move around in a circle to the right or to the left. I'm going to go this way, clockwise, and I can see that this angle right here is right beside this one. Well, how would I name this angle here? Well, that would be angle ACB. And remember, you'll see two letters that are the same, which in this case is C and B because that's the segment that they share. All right, let's work on finding a pair of supplementary angles. To do so, you have to just find a straight line. And there are two different straight lines here, so we can see different amounts. But I'm going to go ahead and use this straight line. Line FD. Now, line FD is made of two parts, and you can either look up or down. I'm going to look down here. We have this part. Do you see that? That's that's a little more than half of the line. And we have this part. Together, these two angles make that straight line. So now let's name them. So we have angle FCE, tracing that blue highlight, and angle ECD, tracing the pink highlight. And these letters could also be backwards, not in any order, but backwards from each other. So if I trace ECD, I could trace DCE. All right, for our next task, we're going to look for a pair of complementary angles. Remember, complementary angles look like an L shape or a 90-degree angle. Now, I see two L shapes, one to the left of this line I've drawn and one to the right of this line I've drawn. But only the right angle to the right is made of more than one piece. Over here, there are two pieces that make the 90 degrees. So I'm going to have to use to the right side. The first piece that makes 90 degrees is this angle here, angle ACD. And the second one is angle DCE. Together, those two make 90 degrees. So to name a pair of complementary angles, I would name angle ACD and angle DCE. All right, next task. Our next task is to find a pair of vertical angles. For vertical angles, we first have to find two lines that cross. Well, here's one line, and it's being crossed by this line. Do you see the letter X? Now, we need to find the ones that are congruent to each other across the vertex. So here how we have this angle. If we go across the vertex, we get this angle, which is congruent to it. So our two vertical angles are named angle DCE and angle BCF. We could have also named this angle angle BCD and angle FCE if we wanted to. All right, last task. If angle ACD is 60 degrees, what is the measure of every other angle in the figure? So it's telling us that ACD is 60 degrees. We can now figure out every other angle in the picture just based on this one fact. Remember, ACE is an L shape. That's a 90-degree angle. So what number do you have to add to 60 to get 90 degrees? Well, you would have to add 30 degrees. 30 plus 60 makes 90. Now see this straight line here, line BE? That's a straight line. Therefore, since this is 90, this side will also have to be 90 degrees because 90 plus 90 makes 180. Angle DCE is vertical to angle BCF, so that means it also has to be 30 degrees. And then last, we have a straight line right here formed by two parts, the 30-degree angle and this angle that we don't know. What will we have to add to 30 degrees to get 180 degrees? Well, we would have to add 150 degrees. Now we have shown what every other angle in this figure is in terms of degrees. So let's summarize what we've learned about angle measurements and relationships in Math Weekly number 16. When lines intersect, angles are formed. There are special names for pairs of angles created by intersecting lines. Adjacent angles are side by side and share a common segment. Supplementary angles are two angles that add to 180 degrees. Complementary angles are two angles that add to 90 degrees, and vertical angles are congruent angles formed by intersecting lines. They are found opposite of each other.